Yes guys, I'm back. This is Azizul Maksud. Today's project is for job ready project, another one, and this is very much handy project. And I made this project precise EKS monitoring, setting up Prometheus and Grafana for Kubernetes observability. Yes, if you add this one in your resume, it will be very much helpful for your job searching very quickly. Yeah, the objectives is like that. Deploy an EKS cluster using Terraform. I'll show also Terraform. Install and configure Prometheus and Grafana using Helm. Monitor EKS cluster metrics, pods, services, and nodes with a custom Grafana dashboard. And provide detailed Terraform scripts and custom Helm values. So let's see. And I will upload this one at my GitHub here, DevOps 0 to Hero. I will upload here. I'll give you the link. And today's this structure is like that I'm showing you. Monitoring Kubernetes with Prometheus and Grafana. So this is the basic structure for Grafana and Prometheus. How this is making the connections with each others. So first of all, Prometheus gathering the metrics from application, pull metrics here. Prometheus is pull based. So this is in the interview question also. Pull metrics and from application, third party application, either way. Third party application is using the exporter, Prometheus exporter. Then here in the Prometheus server, it's stored data in the local storage. So normally in the interview, if asking for Prometheus, you can say that it's storing metrics data. It has own database. This is the local storage like that. Then service discovery is using the one find targets. Then pulling from the application is pushing the alert to the alert manager. Using the alert manager is pushing to the alert to email, PagerDuty, Slacks, either way. The third party any application is here. Then Grafana making the PromQL, Prometheus query language, this is special language, PromQL. So Grafana dashboard data visualization is using the PromQL, Prometheus query language. So please keep in mind not many things. Pull metrics, push alerts. Prometheus pulling the metrics from applications, either way, third party or your main application or production, either way. But it's pushing the alerts through alert manager. Keep in mind the alert manager. And Prometheus is has the data storage. So it is storing the data. So pulling the metrics, keeping itself first. Then is giving the alerts through alert manager straight to the email. Just think like that. And Grafana dashboard is showing you everything through the PromQL, Prometheus query language. So, okay, just forget anything else. Then here, this is more details here. Just keep in mind here three metrics. Which one? Host metrics, Kubernetes metrics, service metrics. So I said you it taking the metrics, right? Pull metrics. So it taking these three metrics. Just keep in mind these three metrics. Host metrics, then Kubernetes metrics, service metrics. It's pulling the metrics like that. Don't make that complicated to your brain. You can see everything is obvious here. And Grafana talking with Prometheus with PromQL, Prometheus query language. Grafana talking with that. And the pushing the alert, these kinds of metrics pulling, then pushing the alert there. And here at the underlying Kubernetes CRD, Prometheus alert manager config, service monitor, pod monitor. These guys are CRD 1, 2, 3, 4, 5 CRD. Okay. So yeah, this is the Prometheus and Grafana strategies. Now Helm strategy. I will use the Helm strategy here also. So in the Helm, without Helm, what is the picture? And with Helm, what is the picture? So without Helm, Kubernetes, think like EKS, Elastic Kubernetes service like that. You can think like that. So a setup Kubernetes YAML file. You have to have first the lots of YAML files. Then you have to update configuration in YAML files before deployment. You have to update. And here I'm showing you first here with Helm, it making the common Helm chart. Helm create, then chart is creating. Then it is creating 4 things, but here I have shown here just one thing for staging, production, and dev, which one values.yaml. Configuration is stored in different YAML files. That means for production, staging, and dev, for different YAML files, the configuration is stored different. Then Helm here is making everything update, everything just up to date and ready for the production, staging, and dev. So Helm making like this very easy life. So here you are doing updating yourself, and here Helm making easy your life. Yes guys, here's my YouTube and it will be updated here. Job ready project. If you come to the playlist here, you can see lots of project here for your job ready. So first of all, I have to create the Bastion one EC2 instance, actually Bastion host. Okay, Ubuntu 22 micro, taking my one. If you don't have, you have to take from here. Okay, then security group, I'm taking my one, default one. Okay, everything looks good. So I need to have the mobextem also. Let's go to the instance. It's showing running, but it's still initializing. That means not 100% running. Copying the public IP here. Session SSH, Control V, Ubuntu, advanced SSH, user key. I've used this one. It's coming. Okay, and I'm taking the next commands from my paste repo. You can also fork this one if you like. I have added lots of paste here. So today I'm using kubectl Terraform. So I'm always updating this one. I'm copying from here. Okay, so first of all, you should be update and fully upgrade. This is very much important, fully upgrade. Then AWS CLI installation should be, so it should be had the first install unzip, then it should be zip file here. Kubectl installation, Terraform installation. I need this guys today. It's taking a bit time. Yes, it looks installed here, but I need one more thing. I need the Helm. So for Helm you have to come here. So for Helm installation is for, I'm using the Debian Ubuntu. So where is Debian Ubuntu? Yeah, this is. So I have to copy from here, then just paste here. So it looks done from here. So Control L. I have to see now AWS version. It needs hyphen version. CLI is installed. Then I have to see kubectl. Yes, it's done. Then I have to see Terraform. Yes, so I'm ready to go now. So first of all, I have to create a folder, mkd or directory. I'm giving the name like EKS monitoring. Okay, cd EKS monitoring. Now I have to create some files, so I'm giving the task commands. Oh, I missed one thing. Touch main.tf, I missed main.tf. So ls. So here is now EKSTF, main.tf, outputs.tf, providers.tf, Terraform, tf vars, then variables.tf, vpc.tf. All are Terraforms here. Now I'm editing providers.tf and I'm adding something there. So I'm using the nano providers.tf. I don't need this one. So here providers AWS region US East 1, then provider Kubernetes. So two providers here, AWS and Kubernetes. Host AWS EKS cluster.eks.endpoint. Token is data.aws EKS cluster auth.eks.token. Then cluster is coming like this way. So Control O, enter, Control X. So provider is finished. Now I have to do vpc.tf. I have to add their site. I'm taking the commands from my node. So beam, I'm using now beam command. vpc.tf. So here module vpc source Terraform AWS module vpc AWS version 3.181. Name EKS monitoring vpc. CIDR is like this way. /16, that means 65,000 IPs there. Availability zones 1A 1B and public subnet, these two guys, private subnet, these two guys also. So inside this VPC CIDR you have to have the subnet like this, 0.1 here and 0.2 here, 3 here, 4 here, like that way, and it becomes smaller than VPC CIDR. It's 24 slash, that means 255 IPs are there. Enable net gateway, true. Single net gateway, true. Okay, so it looks good. Ask WQ is done from here. Now I have to edit the EKS.tf. So I'm copying from my node EKS1. Control L. I'm using nano now. EKS.tf. Okay, so this is the module, EKS module, source Terraform. This way I'm not reading now. Cluster name, EKS monitoring cluster. Then cluster version 125. I'm changing the version, this one. I'm changing this version now. 130 is going on, man. Then subnets, then module, this one, VPC ID. So it's copying from there. Then name, node group. So EKS nodes, deset capacity 2, max capacity 3, minimum 1. Instance type T3 medium. So deset capacity is 2. Okay, it's okay for me. T3 medium. Okay, it's good. So Control O, enter, Control X. So EKS done. Now I have to do outputs.tf. I'm taking from my node. So I'm using nano again. I like nano vastly. Okay, outputs.tf. Output EKS cluster name value module.EKS. The name will come from EKS module. There is the cluster ID there. Okay, then output EKS cluster endpoint value module.EKS cluster endpoint. So from EKS module it will call this output. Which one should be called? The output, the endpoint and name, both guys should be called from EKS module. Control O, enter. Okay, then Control X is done. So Terraform init, it's initializing. It's taking a bit time. Yes guys, I need to do AWS configure. So here access key, I have to make first the user. I'm making the user like today, EKS monitoring. Next, attach policy directly, administrator access. Next, create user. So this one, right? security credentials. I have to have the access key for CLI. Confirmation, next, create. So normally in the industry or real time you have to download this one, but I'm deleting after this demo. I'm just taking the copy from here. Default region US East 1. Output is JSON. Now let's see AWS S3 LS working. Yeah, this guys I have. Okay, it's good. So guys, now Terraform validate. It's taking a bit time. Success. So Terraform plan, let's see. So yes, here 21 should be added. So now Terraform apply. I'm giving auto approve, so no problem with yes. It will take times. Yes guys, it looks that apply completed. Okay, so it's good everything. Let's see Kubernetes. Here is EBS CSI driver also found, and here is instance running 3, that means 2 extra. Then auto scaling group created. Let's see the instances. This is the node actually created from here, and I have to see now with the alias. I'm creating alias k equal kubectl. So k get node. If you like this one, this is not coming. So I have to do AWS EKS update kubeconfig. So update kubeconfig. This is also interview question, sometimes asking why kubeconfig should be updated. Because you have to attach this node with this remote AWS region. The region is here. I'm using US East 1. And cluster name is December 31 EKS. Yeah, it has been given the context here. That means updated. So kget node. Now the node has come here. Now I have to add Prometheus and Grafana repo. So copy from here, just straight. This is the Helm repo, Prometheus Grafana. Successfully done. Then create namespace for monitoring. So kubectl create namespace. Copy. Okay, it's created. Then custom values.yaml for Prometheus. So I have to do the values.yaml first. Copying this one from here. So I'm doing nano, then values.yaml, and inside I have to do this one, alert manager. Control C. So alert manager is for Prometheus. Enable true Prometheus spec. So yes, values for service. This one selector, resource, request, memory. Memory is 400 MI, CPU 100 M. Okay, I need the alert manager with Prometheus, this one. So Control O, enter, Control X. So this is done. Then I have to install Prometheus. Helm install Prometheus. I'm copying this guy from here. Okay, It's installing the Prometheus now. It's following the values.yaml, this one. I created now. So according to the values.yaml, that is the alert manager, it's installing the Prometheus. It's taking a bit time. Yes, deployed. So when using the Helm especially, so always coming the deployed. Now I'm customing values.yaml for Grafana. That means I have to edit the values.yaml again. Then admin Grafana password, I am passing there Grafana pass. This is very much important. I'm showing you something. Okay, Control C, then Vim values.yaml. I'm just cleaning everything, just pressing D, insert. Okay, then admin user Grafana should be admin. Here is the admin password Grafana-pass. You can change also as you like. If you don't change here, then you have to take from the CLI with other command. Data source is coming like this way. Name Prometheus, the data source Prometheus. See here, Prometheus is the data source. It is clear, right? And you have type this is the Prometheus. Okay, access dashboard providers. Now the dashboard provider has come default like this way. Okay, dashboard default Kubernetes cluster JSON is like this way. Okay, so ask colon wq is done. Okay, so then install Grafana. Helm install Grafana like this way from values.yaml. Copy. Okay, Grafana like this, namespace monitoring is following the values.yaml. Okay, so it looks installed. Grafana pod is terminated. Okay, it's okay. So main thing is our status, this is deployed or not. This is the main thing for Helm. Always watch the status. Should be deployed. Name Grafana. We are good now. Okay. Then expose Grafana and Prometheus. Expose Prometheus using a load balancer. Give CTL edit service. This one. Then change type load balancer. Okay, I have to expose this one. Copy. Edit service Prometheus. Okay, so now I have to change the type. This type I'm copying the load balancer. So type should be insert mode. Here the type cluster IP. It should be load balancer. Okay, so ask colon wq is changed. Now expose Grafana using a load balancer. Give CTL edit service Grafana monitoring. Also that one should be load balancer. It's coming. Insert mode. Okay, type it should be here load balancer. So I'm just copying because sometimes typo problem. Ask wq is done. Now get the load balancer URL. Give CTL get service, then monitoring. Okay, here's the Grafana load balancer. It has given. We found the load balancers here, 2 load balancers. So VPC, same VPC. Okay. Internet facing. DNS name is here. Let's see the DNS name with Yes, Grafana has come here. So from our instruction, our username is admin and password is Grafana pass. Okay, so let's try with this one. Username is admin, password Grafana pass. Oh la la, Grafana has come and I'm so happy now. Let's go to the dashboard. Okay, then see here, create dashboard, visualization, import a dashboard. Okay, save, discard changes. You can import your dashboard like this way. Then alerting, you can add from connection here, add new connections. Like alert manager, you must need Amazon managed services for Prometheus. You may need Athena, Redshift, Aurora. Either way, you can need this one. Like alert manager, add new data source. So you can make the default URL here also. You can add this way. Save and test. So you need to have a URL like this way. Okay, if you have the URL in the project, your manager will give you the URL. You can use this URL also like the alert manager service like this way. Let's see the just get namespace. We can see here how many namespace here is the monitoring, right? So we can see also get port with using the monitoring one namespace. So here see the alert manager. Okay, and everything is ready and running. See, everything is ready and running. Grafana, Prometheus, Prometheus Cube, Prometheus State, Prometheus. Oh my goodness! See here how many Prometheus? 1, 2, 3, 4, 5, 6. So 6 port at least needs for Prometheus and extra one alert manager for Prometheus. See, very much important. And Grafana just dashboard is just one. So from here, from this monitoring namespace, you can realize how much important Prometheus database. Just to show up how much spaces is taking the Prometheus database. Okay guys, I think it was helpful for you guys. If you like, please consider for subscription like that. Okay, thank you guys, have a great day.